Alright, so this is the chapter of congruency and similarity. Okay, so what is congruency? Okay, so we hear this word congruency, right? Congruency means if I have two triangles, okay, and these triangles are exactly the same size, the same shape, so they are congruent. Okay, so congruency means I have the same size and shape triangles. Okay, so of course in maths, right, just by looking at the size and shape is not enough. I need tests to prove that they are congruent. Okay, so there are about 4 tests to prove that two triangles are congruent. Okay, so for the first test, take a look at this first diagram. Okay, we have these two triangles. You can see that they're exactly the same size, same shape. But how do I prove to the examiner that they are congruent? Okay, so maybe I write down the vertices first. So A, B, C. Okay, D, E, F. Okay, so these are the vertices. Okay, so as you can see, we are given only the length, right? The sides, the length of the sides. So this test is what we call side, 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 SSS. Okay, so right, so let's see. Number 1. Okay, so we know that AB is equal to DE. Okay, so I must write AB is equal to DE. Okay, notice the alphabet. Notice the order of my alphabet. I didn't write AB equal to ED. Okay, because if you write that, it's not correct. You must write DE. Okay, because A corresponds to D, and B corresponds to your E. Right? So number 2, we know that BC is equal to EF. Not FE, is EF. Okay, so number 3, last but not least, is AC equal to the length of DF. Okay, DF. Right, so I've proven the side test. Okay. So yeah, so this is the first test. Okay, so for the second test, okay, let's just say we are given 2 triangles again, and this triangle has 2 lengths and 1 angle. What is the test to prove that they are congruent? Okay, so since we see, right, side, angle, side, right? So our test is called side, angle, side, SAS. Right? So let me denote down the vertices. Okay, so A, B, C, D, E, F. Okay, so first let me just prove the side. AB, right? Okay, sorry, maybe I just write, okay lah, BA. Okay, so the length of BA is equal to the length of EF. Okay, EF. Okay, because B is at the angle there, right? And E is also at the angle there. So we know that B is the vertex B, right, is equal to the vertex E. Right? Okay, so BA equal to EF. The order is very important. If you write BA equal to FE, means you are wrong already. Right? Okay, so second we go to the angle, because here, right, A, right? So our angle is the same for 51 degree. So angle ABC is equal to, right? So is equal to angle FED. Okay, because I start from A, right? So I go through the length of 8 cm first. Then until I reaches B, I go to the length of 10 cm. So for the second triangle, I must do likewise. Okay, so the F, I go through the length of 8 cm. And after that, I go to E already. I reach E already, right? I go to D of 10 cm. So it's FED, FED, right? Okay, last but not least, another side, right? Okay, so okay, so not angle, BC is equal to the length of 10 centimeter, so it's equal to ED. Okay, ED. So I've proven that these two triangles are congruent. Okay, so this SAS. Alright, okay, so let's go to the third test. Third test, you can see that we are given okay, these two triangles doesn't look the same size, but it's the same size, okay, due to some drawing thing. Okay, so we are given two angles and one length. Right, so if you see from left to right, the first thing you will see is angle. Okay, the second thing you will see is the length. The third thing you will see is another angle. So this is what we call angle, side angle, ASA. Alright. Okay, let me write down the so-called the vertices again. A, B, C. D, E, F. Okay, so let's deal with the angle first. Okay, so I want to prove the 23 degree. Okay, so angle C A B. Okay, so angle CAB is the 23 degree, right? Is equal to the angle EFD. Okay, because your C is at the 1, 2, 4, the vertices, right? So my second triangle must also be at the 1, 2, 4. Then after that, I go through the length of 8.9. Okay, yeah. So it's the order. EFD is the order. Second will be the side. Okay, the side is the 8.9, right? So maybe I just write AC is equal to so A is at the 23 degree, right? So it's here. Alright, so it's equal to length of FE. Okay, so I've proven angle side. I need to prove another angle. So number 3 will be the 1, 2, 4. Okay, so angle ACB is equal to so our second triangle is angle, since the vertex A, right, starts at the 23 degree. So I must start at F. Angle F E D. Okay, yeah. Alright, so the order is very important. Right, last but not least is a very special test. Okay, so this test only applies to right angle triangle. Okay, if I have two right angle triangle, I can use this test. So you notice that we are given this side, we are of course given the right angle, and of course last but not least another side. But this side has a very special name. This is what we call the hypotenuse. Okay, so this is the longer side, right? Longer side of your so-called right angle triangle. So our test is what we call right angle hypotenuse side. Not right hand side, it's right angle hypotenuse side. Okay, let's test for the right angle. Okay, right angle is the easiest to test, but before that I must write the vertices. A, B, C, D, E, F. Alright. Okay, so the first side will be the right angle. Okay, so angle A, B, C is equal to angle EDF, right? Angle EDF. Right. Okay, the second test will be our hypotenuse, the longer side. So the longer side is 7.9, right? So our AC is equal to EF. Okay, EF. Okay, the last but not least is our another side. Okay, 5.2, right? So the length of AB is equal to the length of ED. Okay, so I've proven my right angle hypotenuse side test. Right? So these are all the 4 different types of tests to prove that two triangles are congruent. Congruent means they have the same size, they have the same shape. Right? Okay. So next we want to prove similarity. Okay. So what is similarity? Similarity means if I have two triangles, but these two triangles they do not have the same size. So basically one triangle is big, another triangle is small. So I want to test this for these two triangles similarity. Alright, okay. For similarity, there is only three tests. Three tests for similarity. The first test is our AA. Angle. Okay, so you notice that we only need two angles to prove two triangles to be similar. Alright. Okay, so let me write down the vertices. A, B, C, D, E, F. Right? Okay, so the first is our 72 degree, right? So angle A, B, C, okay, is equal to angle E, D, E, D, F. So this is the 72 degree. Okay, so I need to prove the second angle. Angle 35 degree, which is A, C, B, equal to angle, so is EFD, right? EFD, right? So this is as long as I prove these two angles is sufficient, because in a triangle, as long as I have two angles inside a triangle, right, 72 degree and 35 degree, I will know the final angle, right? So two angles is sufficient enough for me to prove that they are similar, right? Okay. Okay, the next test will be okay, so let's just say we have two triangles again. Okay, so now you look at the one of the triangle. Okay, we are given the length. We are given length, we are given an angle, we are given another length again. So this is something like our so-called side angle side, right? Okay, but I would like to call it one angle, okay, two proportion. Okay, so yeah, all right. So okay, so first thing I need to before that write the vertices B, C, E, A, B, C, D, D, E, F. All right. Okay, so let me test for the angle first. Okay, so angle is the 122 degree, right? So 122 degree, angle A, B, C is equal to angle, angle A, B, C. So it's equal to angle D, E, F. Okay, so later I will tell you why it's not F, E, D, D, F instead, right? Okay, so now I go to the two proportion, right? So you notice that for the triangle ABC, we have one side that is shorter and another side that is longer. Okay, so this is longer. And for triangle DEF, right, we have also another. This is longer, right? Okay, and the 4 centimeter is shorter. Okay, so this is shorter. Okay, so the shorter must correspond to the shorter. The longer must correspond to the longer side. Okay, so and one more thing is that when I use the longer, I use the ratio of the shorter and the shorter of both triangle. The ratio must be the same. Okay, so let's see what I mean. Okay, so number 2. Okay, so let's just say I want to deal with the longer side. AB, okay, divide by AB divide by DE. Okay, DE. So AB has a length of 7.5 centimeter. DE has a length of 6 centimeter only. Alright, so if you find the ratio 7.5 divided by 6, you'll get about 1.25. Okay, so the ratio between these two lengths is about 1.25. Alright, so if my two triangles are similar, means that this and this the ratio between these two must also give me 1.25. Okay, so number 3. Okay, so length of BC divided by the length of EF. Okay, so BC is about 5, EF is about 4. Okay, so yeah, so 5 divided by 4, I should get 1.25. So you can see that the ratio is the same. Alright, so I can say that since I have angle the same, my two proportion is also the same. So A, B divided by D, E is equal to B, C divided by E, F, which is equal to 1.25. So I have proven my two triangles to be similar. As long as you can prove this angle and one proportion and another proportion, then it's enough to prove that these two triangles are similar. Alright, okay. So now we go to the last test. Okay, last test, you can see that we are not given any angle. We are only given all the length of the sides, right? The three sides of a triangle. Alright, so you can take a look at this ABC, triangle ABC, right? Okay, the shortest part, okay, so the shortest is this. Okay, the longest is your 8, right? Longest, sorry. Okay, for your XYZ, the XZ is the longest length, and the shortest will be your XY, which is this. Okay, and of course there's a medium length. For BC is medium. Okay, so YZ is medium also. Okay, so how do I test for it? Alright, so this is what we call tree proportion. Okay, so so let's take a look. Okay, so I compare my AB and XY first. So because my AB corresponds to the XY, the shortest compare with the shortest. Okay, so number one, AB divide by XY. Okay, so you should get AB is about 4, your XY is about 5, so it's about 0.8. The proportion is 0.8. Number two, okay, so number two, I compare the medium one. Okay, so medium is BC divide by YZ. Okay, YZ. So BC is about 6, YZ is about 7.5. Okay, so if you calculate, you should get 0.8 also. Alright, last but not least is this. Okay, the longest. So AC divide by your XZ. Okay, so AC is about 8 and your XZ is about 10. So of course, if you manipulate, you should get 0.8. So I proven that all these three proportion is the same, 0.8, 0.8, 0.8. Okay, so I should write down my test, right? Okay, so it's maybe I write here. Okay, maybe I write here. Right, so it's equal to A B over X Y equal to B C Y Z equal to A C X Z. Okay, so you just write down the proportion 0.8. Alright, so yeah, so this case we have proven that the two triangles are similar.